Today we're doing key features of functions. X-intercepts are where the function crosses the x-axis. And if you need more time to write, just pause the video and catch up. X-intercepts always have a 0 for the y-coordinate. So there is the value where it crosses the x, and then there's always a 0 for the y-coordinate if it's an x-intercept. The y-intercept is where the function crosses the y-axis. And y-intercepts always have a 0 for their x value, and then the value where it crosses the y-axis goes in the y-coordinate spot. Domain is your input, which a lot of times means your x values. If you're looking at a graph for the domain, you want to go left to right if you're looking at a graph. The range is your output, which is your y values most of the time. Not always, but most of the time. If you're looking at a graph trying to determine range, it is bottom to top. The maximum value is the highest point. And if it's just looking for one number, it's looking for the y value. The minimum is the lowest point. And once again, if it's only looking for one number, it wants you to take the y value. To determine if a function is increasing or decreasing, you want to trace it. And again, you're going to go from left to right. All right, so let's look at this first example. This is linear because it makes a line. And let's talk about all the things we know about it. We know that the x-intercept is where it crosses the x-axis. So here's the x-axis. It crosses the x-axis at -1, and that's an x value, so it goes in the front, and then you put a 0 for the y value. The y-intercept is going to be where it crosses the y-axis. And it crosses the y-axis right here at +1, and that goes in the y value spot, which is going to have a 0 in the front. The domain of this function, you look at the x values. Well, this function has arrows on the left and an arrow on the right, so it goes forever. Its domain is all real numbers. Same thing for the range. If you look at the bottom and the top, there's an arrow on each end, so that's also going to be all real numbers. There is no maximum because it goes forever, so there's not a highest point, it goes forever. There's no minimum because there's no lowest point, it goes forever. So is this one increasing or decreasing? So you start on the left and you trace it. This one is increasing. Okay. Example 2 is a table. Let's first talk about the x-intercept. The x-intercept has a 0 for the y value. So right here is your x-intercept, -2, 0. Your y-intercept has a 0 for the x-coordinate. So the y-intercept is 0, 4. The domain is your x values. So in this case, our domain is -2, -1, 0, and 1. It's your x values. Your range is your y value. So it's 0, 2, 4, and 6. The maximum would be the highest point. And if you have to choose between x and y, you'd look at the y. So the highest point would be 6. So the maximum is 1, 6. The minimum is your lowest point. Again, you look at the y's for the lowest point, so that would be -2, 0. And is this one increasing or decreasing? Look at the y values. It is increasing. All right, example 3. Example 3. Your x-intercept is where it crosses the x-axis. Crosses the x-axis at 0, 0. Where does it cross the y-axis? Also at 0, 0. So your y-intercept is also 0, 0. The domain is your x values. This one we're going to write as an interval. The x's go from -3 to +2, and it stops. These circles mean that it stopped. There's no arrows. The range is your y value, so you're looking at the y-axis. The lowest point is -3. The highest y value is 4. The maximum is the highest point. The highest point on the graph is right here, -3, 4. The minimum is the lowest point, which is right here, 2, -3. Is this one increasing or decreasing? It is decreasing. All right, example 4. Your x-intercept, once again, where does it cross the x-axis? This one is also 0, 0. Your y-intercept, where does it cross the y-axis? Also 0, 0. The domain is all real numbers because it goes to the left forever and it goes to the right forever. But that's something you don't really have to know for this class. You'll learn in Math 2. So the domain's all real numbers. The range is your y values, and the y values start at 0 and they go forever to infinity. Again, you don't need to know that for Math 1. You need to know it for Math 2. This one does not have a maximum value because it goes up forever. It does have a minimum value. This is the lowest point, and that is 0, 0. And this one's not increasing or decreasing. It does both. If you start here and you trace it, this side is actually decreasing, and then this side is increasing. So this side is actually decreasing, and this side is increasing because you go from left to right. Example 5, a piano is being lowered from an apartment that is 18 feet above the sidewalk. The piano descends at a constant rate. The piano's elevation over time is represented by a linear function graphed below. All right, so once again, we'll start with the x-intercept. Here's your x-axis. I know those numbers are hard to see, but that is a 6, and you write that as 6, 0, a 0 for the y-coordinate. The y-intercept is where it intersects the y-axis, so that would be over here, and that is at 18, 0, 18. Your domain is your x values. This one starts at 0, and it stops at 6. Your range is your y values. This one, the y's start at 0 and they stop at 18. The maximum is the highest point, which also happens to be your y-intercept. So the maximum is 0, 18. The minimum is the lowest point, which is also your x-intercept on this one. So the minimum is 6, 0. And is this one increasing or decreasing? It is decreasing. All right, domain and range in context. Real numbers can be decimals, fractions, Integers are whole numbers, so no decimals or fractions. Once again, pause this video if you need more time to write. Example 6, the function c of p equals 8p plus 25 gives the cost of hosting a party for p number of people. The room can only hold 30 people. What is the practical domain? All right, so we said domain was x values. More importantly, domain is your input. And this problem, your input is right there. It is p. What does P stand for? P stands for people. Well, can you have decimals or fractions when you're talking about people? No, it has to be whole numbers. So it has to be integers. Do my people have to be less than or equal to 8 or less than or equal to 30? They have to be less than or equal to 30 because the room can only hold 30 people. Example 7, the attendance for a school play is a function of ticket price as shown below. What is the practical domain for this function? Well, when you have a graph, the domain is your x value. So here's the x, and let's look at our x values. It starts at 0 and it ends at 50. So our answer has to have 50 in it, which makes it C. Number 8, a tractor trailer is driving up a mountain. H of t represents the height at which the truck is currently at, and t represents the time that it has been driving. And they give you the function. What is a reasonable domain? Well, it would be really helpful to see a graph for this one. So let's put it in Desmos and see what the graph looks like. H of t equals negative 16 t squared plus 32t plus 8. And remember, domain, we're looking at the x values. So here are your x values. It said, what is a reasonable domain? And it's a tractor trailer driving up a mountain. A tractor trailer cannot start at negative, it cannot have negative time. You look, your x value is t, and so the x is talking about time. You cannot have a negative time if you're being reasonable. So the tractor trailer actually started here, and it's driving up the mountain, and then it's going to come down the mountain. So the time that it takes, the time would start at 0, you can't have negative, it start at 0, and then it would go to 2.225. So 0 to 225. Oh, I'm sorry. That was a mistake. This one would be real numbers because you can have decimals when you're talking about time. We have a decimal right here in our answer. So real numbers can be decimal, right? You can have half an hour. So you can have decimals when you're talking about time. All right, last one, example 9. The amount of bacterium B in a container at a certain hour after 3 p.m. H is given by the equation B equals 2 times 3 to the H. What is the practical domain of this equation? So domain is x values, or if you don't have x values, it's your input. So your input is here, which is H. And what does H stand for? H is hours after 3 p.m. So that would be answer B.